Okay, today in IM2 we're going to cover 7.5, which teaches us about the other quadrilaterals, trapezoids, and kites. So the first one we're going to talk about is a trapezoid is a quadrilateral with exactly one pair of parallel sides. In this diagram, it's these two, and the bases are the parallel sides, okay? The base angles are the angles that share the base. So these would be the base angles to each other. These would be the base angles, okay, to each other. And then the legs of the trapezoid are the non-parallel sides. So it's important that you understand there's one special trapezoid called the isosceles trapezoid. And if the legs are congruent, then the trapezoid is an isosceles trapezoid. And those have some special properties that we'll learn about later. Okay? So, an if and only statement, which we've talked about before, is called a biconditional statement because it consists of two separate conditional statements rewritten as one statement. It is a combination of both a conditional statement and the converse of that conditional statement. A biconditional statement is true only when the conditional statement and its converse are both true. So look at this one. The original statement, if a trapezoid is an isosceles trapezoid, then the diagonals of the trapezoid are congruent. The converse is, if the diagonals of the trapezoid are congruent, then the trapezoid is an isosceles trapezoid. So since both are true, you can rewrite it as a biconditional statement. You write the original statement, if and only if, and then write the converse. So here it is. A trapezoid is an isosceles trapezoid if and only if the diagonals of the trapezoid are congruent. So that's just a little more information about biconditional statements. Okay, so here's some theorems about isosceles trapezoids specifically. So if a trapezoid is isosceles, then the pair of base angles are congruent. So these are congruent. Notice that the base angles apply to the ones that are connected to the same base. Okay, in a regular trapezoid, those base angles are not congruent. So it's important that you understand that this is only applying to isosceles trapezoids. The isosceles trapezoid base angle converse, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. The isosceles trapezoid diagonal theorem says a trapezoid is isosceles if and only if its diagonals are congruent. So if and only if. So if the diagonals of a trapezoid are congruent, then it's an isosceles trapezoid. So it goes back and forth. Okay? That's what we just learned about. All right, so this is on page 247 of your journal. They want you to find the measure of angle K and the measure of angle L. So the first thing you want to do is you want to look at your diagram. What do you see? So I see that these sides are congruent, which means that this is an isosceles trapezoid. So now I know that this angle is 23 degrees. Now I know that the sum of the angles of them is 360 because it's a quadrilateral, so the sum of all the angles is 360. And I'm going to go 2 times 23 plus 2 times the missing angles equals 360. So I get 46 plus 2x equals 360. I'm going to subtract 46 from both sides. I get 2x equals 314, so x equals 157. So that means this angle is 157 and this angle is 157. So make sure you remember that you're talking about two angles and not just one. And it all has to add up to 360. There we go. Okay, now we're going to learn about the trapezoid midsegment theorem. The midsegment of a trapezoid is the segment that connects the midpoints of its legs. So we find the midpoint, and we connect them. It does not have to be an isosceles trapezoid, okay? But that these are congruent. Now, what's special about it? So the midsegment of a trapezoid is parallel to the base. So notice the two bases are parallel, so all three are parallel. And its length is 1/2. So the length of MN is 1/2 of AB plus DC. Okay, so we add those, and this is 1/2 of that. Okay, in IM2, one of the important things you need to remember about all of these theorems is you're not just going to use them in proofs. You're going to be using them to solve geometric problems mathematically. So that's what we're going to do on this page. This is number 5 and 6 in your journal on page 247. So I have to solve this one for CD. And I can see that CD is a base. And by these notations, I can see that MN is a midsegment. So I'm going to write up what I know first. MN equals 1/2 of AB plus CD. Okay, now I'm going to plug in the numbers that I have. 1.8 equals 1/2 times 0.6 plus, don't know CD, so I just leave it. I'm going to multiply both sides by 2 to get rid of that fraction. And I get 3.6 equals 0.6 plus CD. I'm going to subtract 0.6, and I get 3 equals CD. There you go. Okay, now I go to the second one. I have to find the value of x. So I can see that there's two opposite sides that are parallel, and so I know it's a trapezoid. And I can see by these symbols here that this is the midsegment. So I'm going to set it up. 3x minus 2 equals 1/2. Now I have to add my bases. So x plus 11 plus 3x plus 3. So I get 3x minus 2 equals 1/2 of 3 plus 1 is 4x plus 11 plus 3 is 14. And now when I get to this point, I could choose to distribute the 1/2 and divide these numbers by 2, or I could multiply both sides by 2, which is what I decide to do. The important thing to remember is to put parentheses on this binomial so that you remember to distribute. So I get 6x minus 4 equals, those are canceled, 4x plus 14. So I'm going to subtract the 4x from both sides. I get 2x, and I'm going to add the 4 to the other side, equals 18. So x equals 9. So check the answer. But before I do just looking at this, I'm going to double check. So that means that this one, x equals 9, would be 27 minus 2 is 25. This one is 3 times 9 is 27 plus 3 is 30. And this is 9 plus 11 is 20. So now I can just do a quick check. 25 equals 1/2 of 20 plus 30, and I can see that it worked. And that didn't take too long. Okay, so using a midsegment in the coordinate plane. So they want you to find the length of the midsegment YZ in the trapezoid. So I could just go ahead and find the midpoint of each line and do the distance formula, but I look here and I go, that is not going to be an easy point to use. So what they did was they found the length of SV and they found the length of TU, and then they plugged them into the formula and got the distance of YZ, which is 3 square root of 5. So if you want to press pause and look at that and see how they did that, it's kind of cool. So remember, if you have this and multiply by half, you only multiply the outer term, the coefficient of the radical. Okay. Now we're going to talk about kites. So one of the sad things about distance learning is we're not doing a lot of construction, but I thought that I would include and show you how to make a kite. You can pause and look at it and see how to do that and figure it out, but we aren't going to be able to do any constructions this year. So what are the properties of a kite? A kite is a quadrilateral that has two pairs of consecutive sides that are congruent. So notice that the consecutive sides are congruent. Okay? But opposite sides are not congruent. So not the opposite sides. So very important. Think about that specifically. All right, so the kite diagonal theorem. If a quadrilateral is a kite, then its diagonals are perpendicular. if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And it is the ones like this, okay? So really important to remember. If you find it has two sets of opposite angles, then it's not a kite. Two sets of congruent opposite angles. Okay, so let's do a proof. And okay, so here's a proof of the kite diagonal theorem. And you can look through this, push pause and read through it so that you can understand what they did with each step. If you have to go back and think about it, then go ahead and do that, okay? All right, so finding the angle measures in a kite. So find the measure D in the kite. So here's the angle, okay? And they gave us angle E and angle G. So what do we know? So by the kite opposite angle theorem, we know that it has only one pair of congruent angles, and these are not congruent. So angle E does not equal angle G, so therefore, that's what that means, angle D must be congruent to angle F. Okay? So now we know by the we know that a quadrilateral equals 360 degrees. So we're going to go the measure of angle D plus the measure of angle F plus the measure of angle E plus the measure of angle G all add up to 360. So we know that D and F are the same, so we're just going to call them 2x. And measure E, angle E is 115, and angle G is 73. So we're going to add those up, and so we get 2x plus 188 equals 360. We're going to subtract 188 from 360, and we get 2x equals 172, and divide by 2, and x equals 86. So angle D is 86 degrees, and so is angle F. And you could add those all up if you want to check your work. Okay? All right, so now they want us to find the measure of angle K and the measure of angle L. So look carefully. Here are my consecutive sides, so I can identify that this is a kite. Okay, remember, you can't always identify it's a kite. You don't just assume. So look at the diagram. Two sets of consecutive sides means it's a kite. And so now that I know it's a kite, I know that one pair of opposite angles is congruent, and these are not those angles. So I'm going to go 2x, meaning that I'm going to call this x and this x, plus 130 plus 90 equals 360. So I'm going to combine my like terms, and I get 2x plus 220 equals 360. Subtract 220 from each side, I get 140, and I get x equals 70 degrees. So both of those angles are 70 degrees. Okay, now for this one, we know that these are congruent. This is a perpendicular bisector of HF, so GE is a perpendicular bisector. So I know that 9 equals 1/10 x minus 1. I'm going to add 1 to both sides. I get 10 equals 1/10 x. And so I'm going to multiply both sides by 10, and x equals 100. So that's kind of a big number, but it's just asking you what is x. So it's not the value of the side. If you plug that in, okay, it equals 9. Okay, so don't let that confuse you. All right, so there's your answers. I forgot they were there. And we're good to go. Okay, so here are all your special quadrilaterals. So we've got a whole bunch of them, and we've divided them up, and you can see what they look like. Okay? And that's just something you might want to pause, maybe print it, something like that that can identify everything for you. Okay, so identifying a quadrilateral. So what is the most specific name for quadrilateral ABCD? So I look at this, I see that the diagonals are bisected. Okay, by the parallelogram diagonal converse, ABCD is a parallelogram. but I know that these are also parallelograms. But there's no information on angles and there's no information on the sides. So the best I can say is that it's a parallelogram. Okay? So, quadrilateral DEFG has at least one pair of opposite sides congruent. What kind of quadrilaterals meet this condition? Okay? All of these, okay, have at least one pair of opposite sides that are congruent. The only one that's left out is the kite, okay? The kite and the regular trapezoid are left out. So it's really important that you understand how to identify. So let's look at this. Give the most specific name for the quadrilateral and explain your reasoning. So first thing I look at, the only thing they've given me is sides, and these are consecutive sides. So I have two pairs of consecutive sides that are congruent, and the opposite sides are not congruent. Therefore, this is a kite. Okay? Number 9. Look at this one. We've got two sides that are parallel. Okay, and we have the diagonals are not congruent. They don't bisect each other, so that's 144. So they are not congruent, so the diagonals are not congruent. And they do not bisect each other. So this has to be a trapezoid. Okay, really important. The diagonals help in a lot of cases. Okay, over here, we know that we have one pair of opposite sides. And how many pairs of opposite sides matters, are congruent. And we know that we have one diagonal is cut in half, but it doesn't tell us about the other one. So the best term we can give this one is a quadrilateral. Okay, we can't go any more than that. That's as specific as we can get. So make sure you're not over-defining and make sure you're not under-defining. So that's all. Take care.